Welcome guys to my YouTube channel. In today's class, we are going to be taking the JAMB Mock Chemistry Questions Dissolve Part 2. Okay, so if you have not watched the previous video, please, I'm going to post the link at the comment section of this particular video. Now let's go into what we have for today. The first question says that the constituent of permalloy as an alloy is what? The constituent of permalloy as an alloy is what? Now, because we are using this video for intense revision for JAMB students, it will be important for you to understand what an alloy is. An alloy is a mixture or combination, not chemical combination, no. An alloy is a mixture of two or more metals. Mixtures of two or more metals. Yes, an alloy is a mixture of two or more weighting metals. Take note of that. So when you are talking about an alloy, certainly it contains two or more metals. Now, an example of an alloy is number one. There's an alloy called bronze. Bronze is an alloy containing copper and tin. Take note of that. We have an alloy called brass. Brass is an alloy containing copper and what? And zinc. Are we together? Yes. We have what we call a coinage bronze. We have what we call a coinage bronze. A coinage bronze is a combination of bronze and brass, and that will give us weighting, copper, tin, and zinc. Take note of that. This is a coinage bronze. Now we have what we call steel. What is the constituent of a steel? Steel comprises of carbon and iron. Take note of that. This is the constituent of steel. It contains carbon and weighting iron. Then we have what we call a stainless steel. A stainless steel. A stainless steel is the combination of what? Nickel. Anywhere nickel is, you have iron, and then you have chromium. Take note of that. You have chromium. This is the constituent of a stainless steel. Now we have an alloy which is called a type metal. Take note of that. A type metal. A type metal comprises of lead, it comprises of tin, and it comprises of antimony. Yes, we have an alloy called duralumin. We have an alloy called duralumin. Duralumin comprises of aluminium, it contains magnesium, it contains manganese, and it contains copper. We have an alloy called permalloy. Permalloy. Permalloy contains nickel and iron. Take note of that. Nickel and iron. So I've given you 1, 2, 3, 4, 5, 6, 7, 8. Now these are examples of what? Alloys. We have what we call soft soda. Yes, we have soft soda. Soft soda comprises of lead and tin. Take note of that. This is also an alloy. So it's either you see bronze in the exam, or you see brass, or coinage bronze, steel, stainless steel, type metal, duralumin, permalloy, soft soda. Then we have one which we call anico. Anico. Anico is an alloy containing aluminium, containing nickel. Anywhere you have nickel, you must have iron, and finally you have cobalt. Take note of that. So these are the basic alloys in chemistry. Now, according to this question, the constituent of permalloy as an alloy is what? What is the constituent of permalloy? Take a look at the constituent here. You have nickel and iron. That's the constituent of permalloy. So it is not A, it is not B, it is not C. The answer is what? D. Now let's take question number 13. In the chemical reaction, this is a chemical reaction between what? Red hot iron and steam. Yes, to give us iron 2 diiron 3 oxide and hydrogen. The reducing agent is what? Let's bring that the chemical equation and look at it carefully. Now, iron reacting with what? Steam to give us iron 2 diiron 3 oxide. which is an higher oxide of iron, plus what? Hydrogen. Now look at this carefully. If I have iron reacting with steam, which is gaseous water, now where is your reducing agent? Where is your reducing agent? Your reducing agent is traceable to the reactant side. Yes, your reducing agent or your oxidizing agent is traceable to the reactant side. Take note of that. So if you are looking for a reducing agent or you are looking for oxidizing agent, it is traceable to the reactant side. Now let's do the analysis of this reaction so that we can determine the reducing agent and the oxidizing agent. First of all, take a look at this iron. Iron is changing from here to this place. Do you see it now? Now, it was ordinary iron, but now it contains what? Oxygen. The addition of oxygen to a substance is known as oxidation. Yes, take note of that. It is known as oxidation. So if I add oxygen to this iron that is here, the process is known as what? Oxidation. Do you understand? Now if I analyze this one, if I analyze this one, which is your water, from water it became waiting, hydrogen. Now the oxygen here has been removed. So if oxidation is the addition of oxygen, then reduction will be removal of oxygen. You see them now? This is water, but now it's now hydrogen. This was iron, now it's now iron 2 diiron 3 oxide. But this is water, now it's now what? Hydrogen. So if this is called oxidation, this one is called waiting, reduction. And you must note this, that it is only reducing agent that undergo oxidation, while oxidizing agent undergo what? Reduction. That is to say, this is our reducing agent, while this one is our oxidizing agent. Why? Because reducing agent undergo oxidation, but oxidizing agent undergo waiting, reduction. I repeat again. Oxidation is the addition of oxygen, while reduction is the removal of what? Oxygen. Do you understand? So they said in the chemical reaction, iron reacting with steam to give us iron 2 diiron 3 oxide plus hydrogen. The reducing agent is what? The reducing agent is your iron, which is what? Your B. So take note of that. Why the oxidizing agent is water that has undergo what? Reduction. So note this, that all oxidizing agents undergo reduction. All reducing agents undergo oxidation. Do you understand? Now let's take the question number 14. The organic compound that will readily decolorize bromine water is what? The organic compound that will readily decolorize bromine water is what? Don't forget that there's what we call test for unsaturation. There's what we call test for unsaturation. To test for unsaturation, we simply use two basic reagents, which is our purple KMNO4, that's potassium tetraoxomanganate 7, and bromine water. Yes, so bromine water. Your bromine water is also bromate 1 acid. Take note of that. This is your bromine water. Now, this one is purple, but this bromine water is reddish brown in color. Reddish brown. So now you must understand that if you want to test for unsaturation, you use either purple KMNO4 that is acidified with H2SO4, or you use bromine water that has a reddish brown color. So you must understand that when any of this compound is added to an unsaturated hydrocarbon, it will automatically be decolorized. Yes. To decolorize means that it will decolorize this purple KMNO4 and become colorless. Yes, like that of water. Or decolorize reddish brown bromine water to become waiting, colorless. So that must be noted, that all unsaturated hydrocarbon decolorize waiting, purple KMNO4 and bromine water. But what do we mean by unsaturated hydrocarbon? An unsaturated hydrocarbon is an hydrocarbon having double bond or triple bond. Yes, double bond or triple bond. If it has double bond, you use ENE in naming of the compound. When it has triple bond, you use YNE. So if we are looking for an unsaturated hydrocarbon that will readily decolorize bromine water, we look for the compound having ENE or YNE in our option. So this one is option A, propane. Wrong. This is hexene, ENE. Take note of that. That means this one is unsaturated. So the answer is what? B. The answer is not C because it's methane. The answer is not D because it's also ANE. So you must know that the compound that decolorize bromine water are the compound with ENE, which is double bond, and the one with YNE, which is what? Triple bond. Take note of that. Now let's hold on for more. Take question number 15. The compound formed when ammonia is bubbled through ethyl ethanoate is what? What is the compound formed when ammonia is bubbled through ethyl ethanoate? Now let's take a look at this, class. First of all, ethyl ethanoate is an alkanoate or an ester. Let's look at the chemical reaction between an ester and ammonia. So first of all, you have RCOOR, which stands for your word ester. Are we together? Now let us distinguish this alkyl from this one by putting a prime here. Yeah, this is a prime. Let's put a prime here to distinguish R from R prime. So we can distinguish these two alkyl from each other. Okay. Now let's add our ammonia. If we add ammonia to an ester, the reaction is known as ammonolysis. Yes, ammonolysis. Take note of that. This must be noted. Now the reaction between ester and ammonia is known as ammonolysis. Now what will happen? Two compounds will be formed, class. Two compounds will be formed. One is called an alkanol. One is called an alkanamide or an amide itself. So we are likely to have R attached to OH, which is known as alkanol, plus R attached to what? CONH2. Take a look at that. This is known as amide. So the chemical reaction between an ester, also referred to as alkanoates, will give us an alkanol and an amide. Now you must understand something. Let's draw the chemical compound here. Before we draw the chemical compound, look at this arrow prime. This arrow prime belongs to the alkanol here. Yes. Take a look at this. The arrow prime is for the alkanol, while the other part belongs to this. Please don't forget that. So in a chemical reaction where you have ethyl ethanoate, ethyl, if you want to write an ester, you begin from the end, ethyl, then ethanoate, CH3COO, ethyl ethanoate plus ammonia. Don't forget that if an ester reacts with water, it will give you alkanol and alkanoic acid. But if it's an ammonia, it will give you alkanol and amide. Take note of that. Like I told you, this guy now belongs to the what? The alkanol. So the product will be alkanol, which is C2H5OH, called ethanol, plus an amide. Which amide will be formed? The remaining part will take that of the amide, which is what? CH3CONH2. Are we together? Sorry. CH3CONH2. This is known as ethanamide. Please, it should be noted. So you have ethanol and ethanamide. Take note that this one belongs to the alkanol, while this part belongs to the what? Amide. So that whenever you want to balance the equation, in case you are having methyl ethanoate, you know how to balance the equation. Take note of that. So you have your ethanol and you have your ethanamide. This is the product, and the reaction is known as ammonolysis. If ester reacts with water, it will give you alkanol and alkanoic acid. The reaction will be called hydrolysis. Don't forget. Listen, if I have RCOOR plus H2O, will give us alkanol plus alkanoic acid. I told you that the end here belongs to the alkanol. This reaction is known as hydrolysis. Take note of that. The reaction between esters and water is hydrolysis, but the reaction between ester and ammonia is known as ammonolysis. Now let's take question number 16. An hydrocarbon with a vapor density of 21. The reason for giving you vapor density in this question is to get the what? The relative molecular mass of the hydrocarbon. Okay, yes, that's why they gave you the vapor density. Contain 36 grams of carbon in 1 mole of the hydrocarbon. Watch this question carefully. The homologous series of the hydrocarbon is what? First of all, an hydrocarbon is a compound containing carbon and hydrogen only. Yes, so we have CXHY to represent the hydrocarbon. Knowing fully well that we don't know the value for X and we don't know the value for what? For Y. So they said that the vapor density for the hydrocarbon is what? 21. So if the vapor density is 21, it means that we have 2 times 21. Why? This is to get the what? Relative molecular mass of the hydrocarbon. Yes, so when you multiply vapor density by 2, you get the relative molecular mass. So relative molecular mass is actually 2 times your vapor density. So if the hydrocarbon has a molecular mass of this, what do we simply do? They told us that the mass of carbon is what? 36 grams. So we are going to put 36 here plus the hydrogen. Let's put Y here, equals to 42 grams. That means 2 times 21, 42. So if we collect like terms, S will be 42 minus 36. Are we together? So Y will be equals to what? 6 grams of hydrogen. So if the hydrocarbon is 42 grams, it means that 36 grams is for what? Is for carbon, while the other one is for what? Hydrogen. So how do we solve this question? Very easy. Remember that what you have here is X. So you have CX of carbon. That's what gave us 36 grams according to the question. Yes, because why? We need to know the number of atoms of carbon. So if CS give us 36 and every atom of carbon is 12, look at it here, 12. You have 12x equals to 36, and x will give us 36 over 12 to give us weighting 3. Are we together? So x is 3. Then for hydrogen, HY is equals to what? 6. And you know that every atom of hydrogen is 1. So you have 1 times y equals to 6. So y will be equals to 18, 6. So the number of atoms of hydrogen is 6. One of carbon is what? 3. So that means that the hydrocarbon, which is CSHY, will be C3H6. Now if you look at this carefully, you will know that it is a what? It's an alkene. An alkene has a general molecular formula of what? CnH2n, meaning if 2 is here, 4 will be here. If 3 is here, 6 will be here. So they said an hydrocarbon with a vapor density of 21 contains 36 grams of carbon in 1 mole of the what? Hydrocarbon. The homologous series of the hydrocarbon is what? We have found out that this guy is known as propene, and because it is propene, it's a member of the alkene homologous series, the one with ENE. So the answer will not be A, the answer is not B, the answer is what? C. Now let's take more questions. Let's take question number 17. An isotope has an atomic number of what? 18. What are the mass numbers of the isotopes X and Y respectively if they contain 20 and 22 what? Neutrons? First of all, what are isotopes? When we talk about isotope, we are talking about atoms of the same element having the same atomic number but different mass number. Now, if they gave you the atomic number for the isotopes, it means that your X and Y, watch carefully, must have the same atomic number. So let's put the atomic number as number 18 here and number 18 here. Okay? An isotope has an atomic number of 18. What are the masses of the isotope X and Y if the numbers of neutron is what? 20 and 22. Like I said, isotopes are atoms of the same element having the same atomic number or the same proton number, but different mass number and neutron number. So isotopes usually have different numbers of neutrons. But whenever we are looking for the mass number here, we will add the number of neutrons to the number of the atomic number to give us the mass number. Yes. So take note. Mass number is equals to neutron number plus atomic number. The atomic number is the same as the number of protons. Take note of that. So mass number that we are looking for is the atomic number that is given to us and the what? The numbers of neutrons. So the first atom S has 20 neutrons. So we add 20 to this so that it becomes 18 plus 20 to give us what? 38. That's the mass number. The other has a neutron number of 22. So you have 18 plus 22 to give us 40. So the mass number here is 40. So the mass number of both isotopes are 38 and 40 respectively. So what's the answer to the question? 38 and what? 40. That is the answer. Question number 18. An aqueous solution of glucose would boil at what? An aqueous solution of glucose will boil at what? Don't forget that adding salt or glucose to water will increase the what? Impurity of the water. And addition of impurity to what? To liquid increase the boiling point. Yes, that means you take longer time to boil. But when you add the same impurity to a solid, it reduces the melting point. So write it as a note. Impurity increases boiling point. Write it down. But decreases melting point. Yes, impurity increases boiling point, but decreases melting point. So if I add glucose to water, I'm increasing the impurity of the water, thereby increasing the boiling point. So temperature higher than what? Pure water. That should be the answer. They said an aqueous solution of glucose will boil at what? A temperature higher than what? The pure water. Pure water boils at 100 degrees Celsius. So if you add glucose to it, it increases the what? Boiling point. The answer is what? A. Next question. The compound given off when calcium carbide reacts with cold water is what? What is the chemical compound given off when calcium carbide reacts with cold water? That is what? Ethyne. Take note of that. Now, listen to me. Listen carefully. If I have an alkane, how is alkane prepared in laboratory? Alkane is prepared in the laboratory by the action of sodium alkanoate plus soda lime. Yes, soda lime. Yes, alkanes are prepared in laboratory by the action of sodium alkanoate on soda lime, meaning RCOONA plus soda lime. What is soda lime? Soda lime is quicklime that has been slaked by adding concentrated what? Sodium hydroxide. Yes, soda lime must be a mixture of quicklime plus sodium hydroxide. This one is concentrated, this one is dilute. So soda lime is quicklime that has been slaked by adding concentrated sodium hydroxide. So at the end of the day, what is taking place in the reaction is the sodium hydroxide. Take note of that. But it contains what? Quicklime. So alkanes are prepared by the action of sodium alkanoate on an alkali, usually soda lime, which is a mixture of these two. But this one will dominate the reaction. That's what you have here. Now, alkenes, take note of this. Alkenes are prepared by what? Dehydration of ethanol. Alkanol. Dehydration of alkanol. Take note of that. Alkanols. When alkanols are dehydrated using conc H2SO4, concentrated H2SO4, it will give us what we call alkene. Are we together? For instance, look at what I'm saying. ROH, for instance, plus conc H2SO4, we remove the water, and what will be left will be an alkene, which is RCH double bond CHR. Yeah. So an alkene will be formed at the end of the day, an alkene with double bond. Take note of that. So whenever you dehydrate alkanol with concentrated H2SO4 and higher temperature above 170 degrees Celsius, the temperature must be very high. and the acid must be concentrated. It must be in excess to form an alkene. Otherwise, the reverse will occur. It will give you ethoxyethane or diethyl ether. Take note of that. Now, finally, alkynes are prepared. Alkynes, the one with YNE, are prepared by the action of calcium carbide on cold water. Now let's take the last question for today's class. The backward reaction for the reaction of ethanol and ethanoic acid is what? What's the backward reaction? First of all, when ethanol reacts ethanoic acid, the reaction is known as esterification. Take note of that. This is esterification. It's going to give us an ester, and the ester that will be formed will be CH3, COO, C2H5, then plus water. This is actually the product of this reaction. Yes, alkanol and alkanoic acid will give us esters plus water. The backward reaction here will be called hydrolysis. I told you because it's happening with water. If it happens with ammonia, it's called ammonolysis. Yes, it's called ammonolysis. So take note of that. The backward reaction is known as hydrolysis. Thank you very much for staying to the end of this video lesson. We are going to continue the JAMB mock questions in our next video. I'll see you when I see you again.